Welcome to your deep dive. Ever just stare up at the night, at all those stars, and think who else is looking back? Because that's what we're diving into. You've given us a ton on extraterrestrial life, a whole bunch of articles and notes,
Mm,
ready to get into it.
definitely. And it's amazing, your sources, they don't shy away from the big picture, how massive the universe is,
Hmm.
but they also bring it back down to earth with these cool clues.
It's true, you almost can't wrap your head around it at first. Billions of galaxies, and each one with billions of its own stars. Like, come on.
It's almost impossible to picture, right? And we haven't even gotten to the planets yet. Think about it. Just in our own Milky Way galaxy, there are probably over 100 billion planets. 100 billion. Even if life is incredibly, incredibly rare, with that many chances, it's got to be out there somewhere, right?
Yeah, like finding a four-leaf clover and assuming it's one of a kind. Just because we haven't found it doesn't mean it doesn't exist. Which actually, that's a perfect transition. Your stuff on exoplanets was fascinating. Just a few decades ago, we weren't even sure if other planets were common, and now we've found thousands.
It's mind-blowing how fast things are changing. And it's not just about finding them anymore, but what they're like. You've heard of the habitable zone,
Mm-hmm.
right? Where it's not too hot, not too cold for liquid water.
The Goldilocks zone, right?
Exactly. But even that's being challenged now. The Kepler mission, it's shown us that even planets outside this zone could still have the right stuff for life. Maybe they've got other ways to stay warm, like tidal heating.
So instead of the sun, it's like internal friction keeping things cozy.
You got it. Which brings us to something else your notes got into that I found really cool, those extremophiles here on Earth.
Those things are nuts. Living in conditions we'd consider totally deadly. Makes you wonder what we consider habitable is kind of narrow-minded.
Totally. They really throw a wrench into our assumptions about life. Boiling hot vents, super acidic water, even the deep ocean under all that pressure, life on Earth finds a way.
Talk about resilient. Makes you think if they can hack it here, what about on those weird and wonderful exoplanets?
Exactly. Imagine a planet around a red dwarf star. What if plants there evolved to use infrared light for photosynthesis? It'd be like alien plant life as we've never imagined. These extreme fall files, they just show us how many possibilities are out there.
Makes you realize we've barely scratched the surface, huh? And speaking of surfaces, your research takes us on this whole tour of potential life-hosting spots in our own solar system with hidden oceans and, wait, methane
Now
rain.
you're talking. That's where things get really wild. Your stuff on Titan, that moon, had me glued. It's got an atmosphere, right, but it's thicker than Earth's, and it's got methane lakes and maybe even cryovolcanoes, these things that erupt with, get this icy slush. It's like, come on, that's straight out of sci-fi, but it's real.
Seriously, the pictures alone are mind-blowing. But before we get too far out there, I gotta say, the stuff on Mars, that really grabbed me. Especially all that evidence of ancient water, riverbeds. Can you imagine? Talk about a long-lost vacation spot.
Right. What was Mars like way back then? Billions of years ago, it could have been warm, wet, who knows? And even now, with that evidence we have of briny water underground, I mean, something could be down there, clinging to life in those hidden spots.
Like a whole hidden biosphere right beneath the surface. Now we're talking. But we've got more stops on this tour, right? What about Europa, with its ocean bigger than all of Earth's combined? And it's all under this giant sheet of ice, right? It's been blowing my mind for years.
It's not just how much water there might be, it's what's happening around it. Those tidal forces from Jupiter, it's like it's constantly squeezing Europa like a stress ball, and all that friction creates heat, enough to keep all that water liquid, even though it's so far from the sun.
So you've got the water, you've got a potential energy source. Is that what gets scientists so excited about Europa? What are they looking for when they talk about it as a possible place for life?
Hydrothermal vents would be huge. Just like on Earth, they could be on Europa's ocean floor, spewing out chemicals that could, well, provide the stuff life needs to get started and keep going. I mean, it's a long shot, but still, the possibility alone is incredible, isn't it?
It's wild. And then there's Enceladus, another moon that's not messing around. This one's shooting plumes of water vapor straight out into space like it's trying to get our attention.
And it's working. Those plumes aren't just water vapor either. They've got organic molecules in them, the ingredients for life as we know it. It's almost like Enceladus is sending us samples to analyze. It's smaller than Europa, sure, but some scientists think it might actually be an even better place to look for life right now.
Okay, so we've got Mars with its potential for past and present life. We've got Europa with its massive hidden ocean. Enceladus is practically handing us evidence. And then there's Titan. This one's playing by a different set of rules, right?
Completely.
Okay.
While everyone else is looking for liquid water, Titan's like, what about liquid methane? Lakes and rivers of it, methane rain.
Uh-huh.
It's mind-boggling.
Yeah.
But it also makes you rethink everything you thought you knew about life, you know?
It's like we're trying to imagine what life would be like if it evolved on a totally different periodic table, you know? But even with all these possibilities, we have to bring it back down to earth a little bit because your research also got into the how do we actually find proof?
That's where things get really tricky.
Yeah.
Because we can't just hop on a spaceship and go look for ourselves. At least not yet. So we got to get creative. And a lot of your sources talked about using telescopes, but not just to see these planets, but to actually look for clues in their atmospheres, these things called biosignatures.
So it's like we're trying to smell what someone's cooking, but on a planetary scale. What kind of things are we hoping to sniff out with these telescopes? Give me the cosmic menu.
Well, think about our own atmosphere here on Earth, right? All this oxygen we're breathing. It's mostly from plants and algae doing their thing, right? Photosynthesis. So if we find a planet with a lot of oxygen, way more than it should have naturally, that could be a huge sign that something's alive down there. Something's making all that oxygen.
A whole alien forest we can't even see, but we can detect their breath. That's wild.
It is pretty wild. And it's not just oxygen either. Methane's another one. It can be produced by geological stuff, sure, but if we find a lot of it, or maybe it's hanging out with other gases that shouldn't really be there together, that's when things get really interesting.
Like finding a peanut butter and pickle sandwich, something weird is going on. But you also touched on something even crazier in your notes, technosignatures.
Ah, now you're talking about looking for other civilizations, not just basic life. This is where we're looking for things like radio signals, maybe even giant structures built by some super advanced aliens.
Okay, that's the kind of stuff that keeps me up at night. What if we find something, but it's not meant for us? Or we pick up a signal that's like a galactic wrong number.
It definitely makes you think, There could be civilizations out there millions of years ahead of us, and we're just starting to figure out how to listen. But even if we never find anything, just the act of looking changes how we see ourselves.
It really does. It makes all our little problems down here seem so insignificant. So where do we go from here? We've covered everything from tiny extremophiles to, well, civilizations that build megastructures. What's the takeaway?
For me, it always comes back to that sense of awe. We haven't found definitive proof yet, but when you think about how many possibilities are out there, how much we're learning, it's an amazing time to be asking these questions.
It really is. Maybe someday we won't just be looking for clues, but actually having a conversation. But until then, the search continues. And there you have it, folks, your deep dive into the search for life beyond Earth. We covered a lot, and I don't know about you, but my brain is definitely full. Thanks for joining us.
Absolutely. And the next time you look up at the stars, remember, we're all part of this incredible mystery, and it's only a matter of time before we start uncovering some answers.